In this video, we'll talk about how to find the equation of a hyperbola given the foci and the vertices. So let's check out an example. Let's say we're told that the foci of some hyperbola has the coordinates -1, -1, and 9, -1. And let's say that we're told the vertices of this hyperbola are 0, -1, and 8, -1. So when we're doing these types of problems, it really helps if you can just sketch out a graph to kind of visualize the values. So we're told that the foci are -1, -1. So -1, -1. Here's the first foci, and 9, -1. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, -1. So here's our other foci. And then we're told that the vertices are at 0, -1. So here's our first vertice, and 8, -1. So that's all the way out here. So we can see that both the vertices and the foci fall on this horizontal line. So what that tells us is that this is going to be a hyperbola that opens left and right like this. And remember that the vertices always open towards the foci. So that's how we know that the hyperbola must be opening up like this. So how can we find the equation of this hyperbola? Well, when we have one that opens up left and right like this, the formula that we use is x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Now, if we had a hyperbola that was opening up and down like this, then the y minus k and the x minus h would be flipped. But in this case, we're just going to use this equation. So first, it helps if we can find the center of the hyperbola, because that has the coordinates h, k. So to identify the center, we just have to know that it falls directly in between both the foci and the vertices. So if we just take the average values of either of these, we can find the center. So for example, the vertices have coordinates 0, -1, and 8, -1. So we know that the center will also have a y coordinate of -1 because it has to fall on this same horizontal line as the vertices. Now to find the x coordinate of the center, we can just take the average of the x coordinates of the vertices. So the average of 0 and 8. So if we want, we can write 0 plus 8 divided by 2. That will be the average. So we'll get 8 over 2, which is 4. So the x coordinate of the center will be 4. So we just identified our center, that's 4, -1. So we figured out what h and k are in this equation. Now we need to figure out what is a squared and what is b squared. Well, a is the distance from the center to the vertices. So let's go ahead and mark our center right here at 4, 1. What is the distance to go from the center to either of these two vertices? Well, we can see pretty easily that that would be 4, because to go from 4 to a positive 8, that would be 4, or to go from 4 to an x value of 0, that would also be 4. So that distance is 4. So let's go ahead and label that right here. We'll say a is equal to 4. Now to find b, we can use a trick where we know that c squared is equal to a squared plus b squared, where c is going to be the distance from the center to the foci. So from this center all the way to the foci, we can see that that would be 5. So c is equal to 5. And if that's not immediately obvious to you, just look at the coordinates. We have a coordinate of 4, -1. How can we get to, let's say, this foci of 9, -1? We would have to add 5 to this 4. So 4 plus 5 is 9. So this distance, c, is going to be 5. So what we can say is we can solve for b, because we know c and a. So we said c is equal to 5. So 5 squared is equal to a squared. A is 4, plus b squared. So let's solve for b. So we get 5 squared, that's 25, is equal to 4 squared, that's 16, plus b squared. If we subtract a 16 from each side, we'll get 25 minus 16 is 9, is equal to b squared. So now we have our b squared that we need to write our final answer. So we can write our final answer as x minus h. H, we said, was the x coordinate of the center, so that's 4 squared over a squared. We found that a was 4, so 4 squared is 16. And then we have minus y minus k. So k is a -1, so minus a -1, that's plus 1. So y plus 1 squared over b squared and we just found b squared is 9, is equal to 1. So this is our final equation of this hyperbola.